While you are sitting in your quiet room right now, a monster in deep space is screaming with energy that should not exist. A hidden galaxy center far across the dark sky is pouring out light so bright that it defies the fundamental laws of physics. Astronomers watching through their instruments cannot believe what they are seeing on their computer screens at this exact second. Something out there is burning through cosmic fuel at a speed that makes our best textbooks completely useless. If you love uncovering the real secrets of the cosmos without any sensational hype or confusing formulas, hit that subscribe button right now. Joining our community ensures you will always be the first to explore these deep space mysteries with us. To truly understand why this strange signal is causing such panic among top scientists, we have to start with the basic building blocks of the universe. Every giant galaxy floating in space is essentially a sprawling city of billions of stars, massive clouds of dust, vast streams of gas, and invisible dark matter bound together by gravity. Our home galaxy, the Milky Way, is home to hundreds of billions of suns, including our own, stretching across vast distances that take light over 100,000 years to travel. At the very center of almost every large galaxy sits an incredible force of nature known as a supermassive black hole. These giant central objects are not like the smaller stellar black holes created when a single isolated star collapses at the end of its life. Instead, these central objects are true cosmic titans that can weigh millions or even billions of times more than our Sun, packed into a relatively compact area of space. Because they hold so much massive weight in one spot, their gravitational pull dominates everything around them for light years. For many decades, popular stories portrayed black holes as giant cosmic vacuum cleaners that simply swallow everything nearby and leave behind nothing but pitch-black silence. But the actual physics of active galaxy centers is far more complex and violent than that old story suggests. When gas, dust, and full stars get pulled toward a supermassive black hole, they do not just plunge straight down into the middle like a falling rock. Because everything in space is spinning, the material falls into a rapid orbit around the black hole, forming a flat, fast-moving ring called an accretion disk. As all that cosmic gas swirls closer and closer to the event horizon, which is the boundary line where nothing can escape, gravity squeezes the matter with tremendous force. This extreme squeezing creates intense friction between the gas particles, heating the swirling material up to millions of degrees. Because the disk gets heated to such extreme temperatures, it begins to glow with unbelievable power, blasting light across the entire spectrum. This radiation includes visible light that human eyes can see, along with powerful X-rays, ultraviolet rays, and intense radio waves. In fact, these superheated accretion disks around black holes can become so intensely bright that they easily outshine all the hundreds of billions of stars in their home galaxy put together. Astronomers call these ultra-bright galaxy cores quasars, or active galactic nuclei, and they are recognized as the most powerful continuous engines in the known cosmos. For a long time, astrophysicists thought they had these giant engines completely understood using a solid set of mathematical rules. They believed that a black hole could only produce a specific maximum amount of light based on its mass and how fast gas was falling into it. But when researchers pointed advanced observatories like the Hubble Space Telescope and the Chandra X-ray Observatory at one particular distant galaxy, their calculations broke down completely. The energy pouring out from this single galactic center was completely off the charts, measuring far beyond what any standard black hole engine should physically be able to create. When astronomers first analyzed the incoming data on their computer screens, they were sure that a mistake had occurred with their instruments. They assumed there was a software bug in the satellite system, a broken detector on the telescope, or a dense cloud of dust skewing the reading. They expected to see a steady, predictable beam of light that matched the calculated size and weight of the central black hole. Instead, their tools recorded immense surges of high-energy radiation blasting into space like an endless, powerful cosmic explosion. To see why this discovery caused such shock among scientists, we must look at a fundamental rule of space physics known as the Eddington limit. Named after Arthur Eddington, a famous British scientist who studied stars a century ago, this rule describes a delicate balance between two opposing forces in space. On one side of the balance, you have gravity pulling gas inward toward the heavy center of the black hole. On the other side, you have the pressure of the intense light itself pushing outward against that falling gas as it superheats. Light might seem weightless and gentle when it hits your face on a warm afternoon, but intense radiation actually exerts a real physical push called radiation pressure. Near a superheated black hole disk, this outward push of light becomes strong enough to shove physical gas away. If a black hole tries to swallow too much gas too quickly, The surrounding disk gets so bright that its outward radiation pressure literally blows the incoming fuel supply right back out into deep space. Once the incoming gas gets blown away, the black hole loses its fuel supply, which naturally causes the brightness to drop back down. Because of this natural safety valve, scientists believed there was a strict, unbreakable limit on how bright any galactic center could ever become. No matter how huge a black hole might be, or how much gas was floating nearby, it was supposed to be physically impossible for light to overpower gravity and cross this cosmic energy ceiling. Yet when researchers carefully measured the light pouring from the galaxy in this new study, they found it was pumping out power at levels way above its theoretical limit. The energy output was so extreme that, according to established physics, the glowing disk should have blown itself apart and shut down a long time ago. Somehow, against all known expectations, this galaxy center found a way to bypass the cosmic speed limit and keep burning fuel at an impossible rate. Did you know that light could actually push physical matter away in deep space? Or is that a fact that surprises you? Tell us what you think in the comments below, and make sure to like and subscribe so you never miss our deep dives into the cosmos. To solve this baffling puzzle, international teams of astronomers began using every major observatory on Earth and in space to examine the galactic core in fine detail. They gathered data across every wavelength of light, using massive radio dishes on the ground, optical telescopes on high mountain peaks, and X-ray satellites orbiting high above Earth's atmosphere. They searched for hidden dust clouds that might be reflecting extra light, looked for signs of recent galaxy collisions, and retested their instruments repeatedly. Every single measurement confirmed the exact same unbelievable result. The galactic core really was producing far more energy than its size allowed. One of the first ideas scientists investigated was the possibility that the center of this galaxy contained not just one black hole, but two massive black holes orbiting closely together. When two galaxies collide and merge over hundreds of millions of years, their central supermassive black holes gradually sink toward the middle of the newly formed galaxy. As they get closer, they form a tight pair, spinning around each other in a rapid gravitational dance before eventually merging into one single supergiant black hole. If two supermassive black holes were locked in such a tight orbit, their combined gravitational fields could stir up the surrounding gas like a giant blender. This extra churning would create massive friction and release double the amount of radiation from two separate accretion disks packed into a tiny space. From billions of light years away, our telescopes might not be able to separate the two individual objects, making it look like a single black hole was producing an impossible amount of energy on its own. However, when astronomers used high-resolution radio arrays to zoom in on the exact core of the galaxy, they did not see the telltale signature of a double black hole system. The light, radio waves, and X-rays were all blasting out from a single, highly concentrated point right at the center. That meant a pair of dancing black holes could not explain the strange surge of energy. Whatever was driving this hyper-powered engine was coming from one central object that was somehow bypassing the rules entirely by itself. With the double black hole idea ruled out, scientists turned to another fascinating concept that involves one of the greatest unsolved mysteries in science: dark matter. We know from decades of space observations that visible matter, like stars, planets, gas, and humans, makes up only about 15% of all the matter in the universe. The remaining 85% is an invisible, unknown substance known as dark matter. Dark matter does not give off light, reflect radiation, or interact with normal matter, but its heavy gravity holds entire galaxies together. Some theoretical models suggest that dark matter particles might gather in extremely dense clouds right around the immense gravitational well of a supermassive black hole. If dark matter particles get packed tightly enough near the center of a galaxy, they might start crashing into each other at high speeds and destroying one another in energetic collisions. When dark matter particles destroy each other, theory says they should transform their mass directly into pure, high-energy light and fast particles. If a massive dark matter destruction event was happening deep inside the core of this galaxy, it could generate a tremendous flood of extra energy that has nothing to do with normal gas falling into the black hole. This extra energy would shine brightly alongside the glowing accretion disk, making the galactic center look like an impossible engine that breaks the Eddington limit. It would mean that the galaxy is not actually breaking the laws of gravity, but is instead using an exotic dark matter fuel source that we have never directly witnessed before. Could dark matter be the secret energy source powering these extreme galaxy centers, or do you think scientists are overlooking a much simpler explanation? Leave a comment below with your guess, and take a second to hit subscribe so you can follow this story as it develops. While the idea of dark matter fuel sounds like exciting science fiction, many mainstream astrophysicists prefer an explanation rooted in powerful magnetic fields. When gas swirls into a supermassive black hole at speeds approaching the speed of light, it becomes so hot that its atoms strip apart into charged ions and free electrons. This creates a churning, superheated state of matter called plasma. As this electric plasma spins rapidly around the center, it acts like a giant dynamo, generating magnetic fields that are trillions of times stronger than the magnetic field of Earth. These intense magnetic field lines do not stay neat and orderly. They wind up tight like coiled steel springs as the black hole spins. As these magnetic ropes twist around the accretion disk, they can act like a physical barrier, trapping radiation and redirecting the flow of superheated gas. Instead of allowing light to push gas away in all directions, the magnetic fields can squeeze the outgoing radiation into narrow, highly focused beams that shoot out from the top and bottom of the disk. If one of these narrow beams of concentrated light happens to be pointing directly toward Earth, our telescopes will intercept an immense amount of radiation. To an astronomer watching from billions of light years away, it will look like the galactic center is exploding with power in every direction at once, far exceeding the Eddington limit. But in reality, the total energy output might still follow the rules of physics, with the energy simply being channeled into a tight, super bright beam aimed straight at us like a searchlight pointed at an eye. To test this beaming idea, astronomers used global networks of radio dishes to map the magnetic structures inside active galaxy cores. What they discovered was remarkable. In these hyperluminous galaxies, the magnetic fields were found to be remarkably organized and immensely strong, creating a state that physicists call a magnetically arrested disk. In this state, the magnetic forces are so powerful that they actually slow down the falling gas and funnel energy directly out of the spinning black hole itself. This mechanism allows a black hole to act as a giant cosmic battery. Instead of just producing light from the heat of falling gas, the system taps into the rotational kinetic energy of the spinning black hole itself. The powerful magnetic lines anchor into the spinning event horizon, extracting energy directly from space-time and flinging it into the cosmos as high-speed plasma jets. When a galaxy center starts tapping into the spin energy of its central black hole, its total power output can skyrocket far beyond traditional expectations. This means the engine is not just burning the fuel falling into it, but is actively draining energy from the rotation of the black hole itself, creating an energy output that seems impossible under older theories. Does the idea of a black hole acting like a giant magnetic battery sound believable to you, or does it sound too crazy to be real? Tell us your thoughts in the comment section below, and subscribe to our channel to join a vibrant group of science enthusiasts. As researchers continued to monitor this strange galactic center over several months and years, they made another fascinating observation. The energy output was not constant. It was flickering, pulsing, and changing brightness on remarkably short timescales. In astronomy, the speed at which an object changes its brightness tells you a lot about how big that object can possibly be. Light can only travel at a fixed speed, roughly 186,000 miles per second, which means information cannot cross an object faster than light can travel across it. If a glowing structure is light years wide, it should take years for the entire structure to brighten or dim, because the light from different parts of the disk takes time to reach us. But this hyper-powered galactic core was changing its energy output over the course of just a few days, or sometimes even a few hours. This rapid flickering proved that the tremendous flood of energy was not coming from a huge, spread-out cloud of gas, but was being produced inside a tiny, concentrated region of space no larger than our own solar system. To appreciate how staggering that is, try to picture an engine smaller than the distance from Earth to the Sun, generating more light and heat than 100 billion full-size stars combined. Packing that much raw power into such a compact volume creates environmental conditions so extreme that matter behaves in ways we cannot replicate in any laboratory on Earth. Atoms get smashed into basic subatomic particles, light itself gets trapped by intense gravity, and space-time gets stretched and twisted like soft dough. This realization marked a major turning point in how scientists view active galactic centers today. For many years, textbook astronomy treated galaxy evolution as a very slow, gradual process that unfolded over billions of years without sudden changes. But watching this galactic engine surge and pulse in real time proved that space can undergo violent, rapid transformations on timescales short enough for humans to observe during a single research project. We are not just looking at cold, ancient history. We are watching an ongoing, high-stakes event unfolding right now in the modern universe. Right now, space agencies are training the James Webb Space Telescope on this exact galaxy to study the chemical fallout of this massive energy engine. With its ultra-sensitive infrared sensors, the James Webb Space Telescope can look right through thick cosmic dust clouds and see how the extreme radiation is impacting the surrounding gas. What astronomers are finding is a dramatic process known as galactic feedback, where the central black hole reshapes the future of its entire home galaxy. The superpowered beams of energy and high-speed plasma jets blasting out from the center act like a massive cosmic leaf blower. They push huge clouds of cold hydrogen gas completely out of the galaxy and into intergalactic space. Because cold hydrogen gas is the primary fuel needed to collapse and form new stars, this hyperactive central engine is effectively starving its own galaxy. By generating an impossible amount of energy, the central black hole is shutting down star formation and preventing any new suns from being born. In a very real sense, the galaxy center is powering itself to death. It is consuming gas so fast and blasting out so much light that it destroys the very environment it needs to survive, turning what could have been a thriving, star-filled spiral galaxy into a quiet, dying island of ancient red stars. This shows us that supermassive black holes are not just passive objects sitting in the dark, but are active architects that control the birth, growth, and death of entire galactic systems. What do you think is more amazing, that black holes can create galaxy structures, or that they can destroy their own star-forming gas? Drop your take in the comments below, and remember to like and subscribe to catch all our upcoming space breakdowns. As we uncover the mechanics of this distant galactic engine, it is natural to ask whether something similar could ever happen closer to our own home planet. At the very center of our Milky Way galaxy, roughly 26,000 light-years away from Earth, lies our own central supermassive black hole, named Sagittarius A star. Compared to the hyperactive monster we have been discussing, our local black hole is currently very quiet, living on a tiny diet of thin gas and occasionally swallowing small asteroids or gas wisps. If you looked at Sagittarius A star today through an X-ray telescope, it would appear surprisingly dim, producing only a tiny fraction of the energy it is theoretically capable of generating. But geological and astronomical evidence collected across our night sky tells us that our galactic home was not always this peaceful and quiet. Our central black hole has gone through wild, violent feeding sprees in the past, and it will almost certainly do so again in the future. Just over 15 years ago, NASA's Fermi Gamma Ray Space Telescope discovered two giant, glowing lobes of radiation extending high above and below the disk of the Milky Way. These giant structures, now called the Fermi bubbles, span over 25,000 light-years in each direction and glow with high-energy gamma rays and X-rays. Detailed mapping revealed that these massive bubbles were carved out by a sudden, violent blast of power from Sagittarius A star just a few million years ago, when early human ancestors were already walking on Earth. This proves that even calm, sleepy black holes like our own can suddenly wake up, swallow a heavy gas cloud or a wandering star, and enter an extreme energy phase. While our solar system sits at a safe distance in one of the outer spiral arms of the galaxy, studying active galactic engines helps us understand the chaotic past of our own cosmic neighborhood. It serves as a striking reminder that the peaceful night sky we enjoy today is just a temporary pause in a long cycle of cosmic activity. Every time astronomers build a sharper telescope or launch a more sensitive satellite into space, we discover that the universe is far more dynamic and surprising than our existing theories predict. This galaxy producing impossible amounts of energy is not just a strange outlier to be ignored. It is a major signpost pointing out the flaws in our current physics models. It tells us that there are still fundamental secrets regarding gravity, magnetic fields, and space-time waiting to be solved by future generations. To really appreciate what this means, we have to think about how these discoveries change our place in the universe. When we look up at the night sky from our small, rocky planet, space can feel permanent, calm, and unchanging. But the reality is that we live in a universe driven by extreme forces that are constantly building, changing, and destroying structures on a scale that human minds can barely wrap around. Knowing that a distant galaxy core can break our rules of physics reminds us how much we still have to learn. Scientists working on these theories are not just trying to solve a single space puzzle, they are rebuilding the foundational laws that explain how energy moves through space. The mathematical equations created to explain these superluminous black holes are already helping researchers design better power systems, improve supercomputing models, and understand plasma physics here on Earth. Science is an interconnected web where understanding a monster galaxy far away can help solve real-world problems right in our daily lives. As new observatories like the Vera C. Rubin Observatory in Chile and space missions like the James Webb Space Telescope continue to scan the deep sky, we will uncover even more of these hyperactive galaxy cores. Each new data point brings us closer to answering whether dark matter, extreme magnetic forces, or brand new laws of physics are responsible for this massive power output. The cosmic story is far from over, and the next big reveal could happen at any moment. If you could travel safely to the edge of an active galaxy and watch a superpowered black hole in action, would you go on that journey? Let us know your answer in the comments. Hit that like button, subscribe to the channel, turn on notifications, and share this video with a friend who loves space mysteries as much as you do. Thank you so much for spending your valuable time with us today as we explored the strange, hyper-powered center of this impossible galaxy. We are truly grateful for your curiosity and support, and we cannot wait to bring you along on our next journey through the mysteries of the universe.